We are going to talk about parallel lines. So you should have already finished the Desmos activity, which should have led you through some parallel and perpendicular line activities. And hopefully you got out of it that essentially parallel lines are lines that have the same slope but different y-intercepts. So let's look and identify and practice some parallel lines. So we have this situation. We need to ask ourselves which lines are parallel. We have 4 lines here, and we need to figure out which ones are actually parallel to each other. It might be pretty obvious to some of us if we have been paying attention, or if you paid attention to the Desmos lesson and actually gleaned out of it what I was hoping to have you glean out of it. But if you didn't, that's okay. Let's look at these 2 lines here, for example. Looking at these 2 lines, we can see they have different y-intercepts, but their slopes are the same. So we can say that these 2 lines are parallel. Now let's prove it to ourselves. So I'm going to graph this first line. I'm going to go up to 3 on the y-axis. Then I'm going to graph this slope of 4 over 3. So up 4 to the right 3. I can't go up 4 and to the right 3 anymore, so I'm going to go down 4 to the left 3. Down 4 to the left 3. So I can finish up, oh, that was down 3, to the left 3. So I can finish up graphing this line. So we can see this line is nice and long, it's awesome. Now let's look at this other one. We have y equals 4/3 x minus 5. So this time I'm going to go down to negative 5. 1, 2, 3, 4, 5, and make my dot. And then I'm going to plot my slope. Up 4, 1, 2, 3, 4, to the right 3. I'm going to make a dot. Up 4, 1, 2, 3, 4, to the right 3. Make a dot. Up 4, 1, 2, 3, 4, to the right 3. Make a dot. And I can even do that backwards here. 1, 2, 3, 4, to the right 3. Make a dot and graph it. If we look at these 2 lines, those lines are never going to cross. So parallel means that they're never going to cross. They are 2 different lines. We know they're different lines because they have different equations because of the y-intercept with same slopes. So they have the same slope, different y-intercept. So let's look at these other 2 lines that we have. We have y equals 2 and y equals negative 3. Y equals 2, if we remember the Hoivux lesson that we did last week, Hoivux. This is a y equation, so that means it's a hoi. That means horizontal, 0 slope, y-intercept. So that means I'm going to draw a horizontal line that goes through y equals 2. So I'll draw a horizontal line through here. This next one, y equals negative 3. Again, hoi. The y-intercept, horizontal line, 0 slope, and it's going to go through negative 3. 1, 2, 3. Draw a horizontal line. All right, so it looks like we have 2 sets of parallel lines. These top 2 equations are parallel lines, and these bottom 2 equations are parallel lines. So those are our sets of parallel. So parallel and parallel. Cool? Cool. Now let's look at them in terms of what they would look like if they were just equations and they were kind of mixed up. So if we look at these equations, we have 4 equations here. We need to identify which lines are parallel. First thing, I want you to always be able to identify the slope. And we can actually identify the slope in 3 out of 4 of these lines. This line and this line are both written in slope-intercept form. So we can see that this one has a slope of 3. And this line just below, line B, has a slope of negative 1/2. So if we have parallel lines, we would need to see another line that has a slope of 3 or another line that has a slope of negative 1/2. If we look at D, this is in point slope form, meaning I can identify my slope and I can identify one point of 1, 5. That's awesome. So we have another line with a slope that we can identify. this last one right here, x plus 2y equals -4, I can't identify the slope yet. So I need to manipulate this equation into a format that I can look at the slope. So I'm going to turn this standard form equation into slope-intercept form because it's easy to do that, or it's easier to do that. So I'm going to subtract x from both sides. So I get 2y is equal to -x minus 4. Then I'm going to divide by 2 on everything to keep the proportionality of that line. I get y is equal to -1/2 x minus 4 divided by 2 is 2. So now I can see my slope on this second line of -1/2. So if I look at these, I can now identify my parallel lines, and I would say line A and D are parallel. And I could also say line C or B and C are parallel. Just trying to keep it in alphabetical order when I write that one. There we go. And so now I can say which ones are parallel because they have the same slope but different y-intercepts. Same slope but different y-intercepts. Cool? Cool. I hope this helped. We have 2 more videos on this. We have 1 more on perpendicular lines. So if you gleaned everything from the Desmos lesson, you might not want to watch that one. You might have it all taken care of. But then the 3rd video might be a must watch for people because we're going to be looking at how to find perpendicular or parallel lines given some information. And that might be a little more tricky. So check that video out if you are good with parallel lines and perpendicular lines. Thanks for watching.